Constructing the ANOVA table. ANOVA stands for Analysis of Variance, and the table itself has the same format as any other design of experiment that we did earlier in this course. The same column, source of variation, sum of squares, degrees of freedom, etc. Now, the sum of square column, the values in here are the same values that we computed in a previous video for each of the factors. So I went ahead and filled them out. Now, as far as the total sum of squares, this would be computed using the Excel function of DEV-SQ if you open parentheses, and you will have to go all the way back to the very first table, and you scan all the replicates. Close the parentheses, and let me center the screen, and that will be your sum of squares, total sum of squares. Now, error had always been figured based on calculation, so it would equal the total sum of squares minus the sum of the sum of squares of all the factors and the interaction factors. Degrees of freedom. Degrees of freedom for any of the factors, since there is two levels, 2 minus 1 is 1. So each and every one of the main factors and interaction factors will have a degree of freedom of 1. Now, for the total degrees of freedom, there was 8 runs and 4 replicates each, which is 32 elements. Minus 1 will be 31 degrees of freedom. Now, for error, it would equal the total degrees of freedom minus all the degrees of freedom for the factors, the main factors, and the interaction factors. Mean square is the average sum of square per a degree of freedom. So it would equal sum of squares divided by degree of freedom. And as you drag this one down, notice that error has more than 1 degree of freedom. Now, for everything else, mean square equals sum of squares, since the degrees of freedom of 1, not for error. Now, F computed is figured based on mean square of a factor divided by the mean square of error. For B, divided by mean square of error. Now, if you add dollar signs to the mean square of error, because as you drag down the cell, you don't want it to shift or drift, you can drag down the cell, and to check your work, you see it then drifts. Now, the probability value for F, we use the Excel F distribution function, which is FDIST, open parentheses, F for the first value, degrees of freedom of the numerator, degrees of freedom for the denominator. For factor B, equals F distribution, open parentheses, F, degrees of freedom for the numerator, degrees of freedom for the denominator. I'm going to enter 24 here so I could drag my cell. And we drag it. Now, as you view your final ANOVA table, let's assume that alpha was 5%. Now, this probability value for A is way smaller than 5%. Same deal for B, C. So all these factors here are significant. Now, AB, AC, BC, and ABC are all greater than 5%, which means we failed to show that they have any statistical significance. So in the final regression model, those will be disregarded.